Hello, and welcome to our presentation for the Smart, Sustainable, Resilient Infrastructure Association. We've put together a zero carbon building report with the assistance of SAIT and Integral Group. So on this call, you've got Tim Nabholz, Associate for Sustainability, and Dan Sudeyko, who did most of the grunt work on this report. What we're looking at here is a high-level overview of how we can possibly get to zero carbon buildings within the Alberta framework in the coming years. So we worked together with Melanie and Alex Kodyra at the Applied Research and Innovation Services Green Building Technologies Group at SAIT and have put together the following report. It intends to cover off a market assessment and implementation forecast of both new and existing buildings as a way to help SSRIA encourage future carbon-focused projects. So we really tried to ensure that what we put together here helped the organization inform decision-making as they move forward. And so this is intended to help SSRIA make better decisions when it comes to approving projects moving forward. Dan, what is zero carbon?
So zero carbon has a lot of different definitions. It can be looked at a lot of different ways. You've probably heard zero carbon, you've probably heard emissions neutral, you've probably heard net zero energy or net zero carbon. They all, in the end, kind of mean slightly the same thing, but just typically tackle it in different ways. So it really comes down to the specific definition of the word and the phrase that you're looking at. So in this report, we were looking at zero carbon specifically, and the definition that we wanted to work with was designing a highly energy efficient building which offsets its annual energy demand through on-site renewable energy while producing no greenhouse gas emissions. So that kind of sets the stage for the entire context of the report and how we were going to try and achieve these zero carbon buildings. So it was important, as I said, to adopt a single definition. It really helps us, it helped provide clarity, transparency, and objectivity in decision making. There was a singular focus and gave the group and team a way forward and a way to decide, which measures we should include in buildings and not. So
the report as a whole focuses on two key timeframes, the short term and the long term. So the most important component of this study is trying to gauge what is possible in the short term. This is the things that will give us the biggest payback in the quickest time. So we wanted to identify those pieces as the most important components for funding consideration. And so that is the piece that we considered first.
So to help achieve this framework and to understand how we should consider the short term and the long term, we looked at 4 different categories that would have to be implemented. So the first was new building construction, second was existing building retrofits, the third was on-site renewable energy, and the fourth was building electrification. And when I say building electrification, that also relates to the grid decarbonization, which will go hand in hand with building electrification. So the way we considered this, like I said, or like Tim mentioned, we looked at it in short-term and long-term time frame. So we really wanted to look at the impact of each of those 4 pieces and how they would have to be implemented in the years moving forward. So when you look at something like energy efficient new buildings, this is something that we can currently do and we can currently put our full force behind. We have the technology to do this. We have the design will to do this and the resources to do this. So this is something that we could put 100% of our effort behind and should be able to implement from current day going forward.
It will also have the biggest impact up front, whereas some of these other ones, if we were to electrify our building at current state, it may not have a beneficial impact as we move forward. So this graph is trying to show where the biggest impact can be made.
Exactly. So like Tim mentioned, with building electrification, currently we're only looking at about a 10% effort that we'd really like to see put into this. Of course, this ramps up over time to 2050 when ideally all buildings will be fully electrified. This again goes hand in hand with grid decarbonization as the grid becomes cleaner and you see more renewable energy and other types of low carbon energy put onto the grid. Once you see coal starting to be removed, then it makes more sense for building electrification to come into place to take advantage of that. When it comes to existing buildings, this is something that could be done, but really is dependent on time frame for building renovations and for equipment lifespan. It doesn't really make a lot of sense financially to implement a lot of these retrofits for equipment that was just installed in the last couple of years. So it makes sense as time goes on to retrofit these systems and to ramp up your effort and your impact as the end of life comes to be. For renewable energy, this one is a little bit tougher to nail down. It's something that could be installed right away on new buildings, but for what we thought was appropriate for this report, when trying to achieve zero carbon, it made more sense to put more of the focus on the building itself, on the new building, and to focus on the envelope and maybe some of the mechanical systems and reducing efficiencies there, putting in heat recovery and putting in different envelope measures that will help reduce energy demand, as opposed to just sticking PV on the building and calling it a day. So as Tim mentioned, the real goal is to achieve short-term goals. This will help set the SSRIA up for success when choosing projects and when deciding what they should be looking for in a project to achieve zero carbon. So this little graphic we have set up here, it kind of shows the long-term versus the short-term goals, and also the time and effort required to achieve those goals and the different scope of how it impacts climate change. So when you're looking at your short-term, you're really looking at coping measures, especially in some of the retrofit market. But as time goes on, you're looking at more substantial adjustments, and then obviously a full transformation of the way we're building buildings in the future. So some of the barriers of adoption, there was 4 key ones that we really looked at when looking at the province of Alberta. The first one is obviously cost and the financial issues that go along with building zero carbon. The second was regulatory and government, like the permitting that's put in place behind it. The third was policy and municipal. So what kind of actual policies are being put in place by municipalities or even by the Alberta government, and what's being done at a ground level as far as how easy it is to implement these buildings. And then the fourth is just an understanding and awareness. And this is really just building education and understanding what a zero carbon building actually is and what it takes to actually implement a lot of these measures. So that can come down to a lot of different things. It can be anywhere from, the designers and the engineers working together and understanding what goes into the building itself, to the contractor and the trades people actually building the building and actually knowing how to build it properly. This can be very important when it comes to air tightness and infiltration, as it really depends on the on-site, like ground level building of the building itself and how well different things are being installed and and just the oversight behind that. So within the report, we put together a matrix that helps describe these barriers of adoption and how the SSRIA can analyze them to help their case moving forward. So the next area we looked at was an impact gap analysis. So this is really looking at key areas of influence where SSRIA could look at its funded projects and decide which areas they should focus on to help maximize greenhouse gas emission reductions. So ideally, when they're looking at a project, there's going to be many different areas that implementing these measures will help, but there was 4 key areas that we really want to note, and that was advocacy, education, incentives, and policy. So if there's a project that's being put together that touches on any of these areas or all of these areas, then that will encourage SSRIA to look at these projects and really to understand how it's advancing net zero within Alberta. So again, we put together a matrix within our report that you can go and look at, and this helps describe the different areas and the different building archetypes that we looked at and what could be done within each of those areas to help advance some of these areas where we feel they need to be advanced in Alberta. So the next part of the report we put together was actually looking at the techniques and technologies that are being implemented within a zero carbon building. So we looked at both emerging and existing technologies. It's very important to note that this isn't a completely exhaustive list, and it's something that will evolve over time as more technologies emerge and become implemented within Alberta. There are some technologies that we're seeing in other parts of Canada that maybe make sense there, but maybe don't make as much sense in Alberta. So it's important to look at this list and know that it's not exhaustive and it can grow. So the focus that we really want to look at was their efficiency, and then their generation and use of renewable resources, and any waste production. And finally, within the report, we actually looked at specific building archetypes and different strategies in which they could be implemented towards zero carbon. So we put together a list of the archetypes and different ECMs, energy conservation measures, and scoped out exactly what we thought each archetype would have to do to help it achieve zero carbon. So we actually looked at 8 different building typologies. The first was single family home up to 3 stories, mid-rise residential up to 6 stories, a high-rise residential, which was 11 stories or more, educational, which only included K-12 schools. This didn't include universities or colleges or any technical colleges or anything like that. The main issue with those buildings and those types of campuses is that every building is different. Some building may require, it might have labs within it. We might have high energy use technologies within the building, and those are much harder to quantify in a general sense. So each of those buildings would have to be looked at individually, whereas this would give us a much better sense in a K-12 school setting where you're seeing more general types of buildings being built. We also looked at warehouses, fire halls, and then we also looked at healthcare clinics and administration. We didn't look at hospitals. Again, these are high energy use buildings, and they're very individual and individualized, and every technology will be different within them, and they'll all have different energy uses. And then the last one we also looked at, which isn't listed here, but we did look at high-rise commercial office buildings.
So our report goes into a whole whack of detail regarding all of the components that we've discussed here today, and I encourage you all to have a look at the report itself. However, I wanted to thank you for taking the time to listen to our presentation today. This was done as a secondary resource because the original presentation that we had presented to the organization unfortunately did not record, and so here we are putting something together for you to go through on your own time, and I hope it's been worthwhile. So thank you very much for joining us today, and take care.